Ionic compounds are compounds which are made between a metal, which are these blue things here, and non-metals, which are the red things. So we need to remember that a metal gives away electron or electrons to the non-metal. So this example, it's sodium and chlorine, which makes sodium chloride, table salt. The sodium is given away its outermost electrons, so now it has a full outer shell, 1, 2, 3, 4, 5, 6, 7, 8. And because it's given away that electron, the sodium has become positively charged. The chlorine has become chloride. It's gained that electron, so now it has 1, 2, 3, 4, 5, 6, 7, 8 electrons. The chloride now has a full outer shell, and because it's gained an electron, the chloride is negatively charged. Positively charged ions are called cations, negatively charged ions are called anions. It's very, very unlikely that you'd only ever have one sodium ion and one chloride ion. So if you have more than one, as you almost certainly will, the positively charged ions and the negatively charged ions arrange themselves in this type of shape. And this type of shape is like a giant grid. It's a matrix, and we call it a giant lattice. And it's alternating positive and negatively charged ions. Now the forces between the positive and the negative ions, represented by these sticks, are strong electrostatic forces. And an electrostatic force is just simply that positive attracts negative, negative attracts positive. So the reason why ionic compounds stick together is because there are positive and negative ions, and positive and negative things attract one another. So because there are these strong electrostatic forces, these require lots of energy to break, and because these strong electrostatic forces need lots of energy to break, ionic compounds have high melting points. So the melting point of sodium chloride is 801 degrees, and the melting point of magnesium oxide is 2800 degrees C. What we're going to look at now is when ionic compounds conduct electricity. So electricity is the movement of charge. So if electrons move, like in a metal, the thing conducts electricity, or if ions move, the thing will conduct electricity. When an ionic compound is solid, it does not conduct electricity. So sodium chloride below 801 degrees does not conduct electricity. And the reason for that is all of the ions are held in position by those strong forces we talked about earlier, and because of that the ions are not free to move, they're held in a fixed position. So because electricity is the movement of charge, in a solid ionic compound there are no free electrons, there are no free ions, so a solid ionic compound does not conduct electricity. However, if you take an ionic compound like sodium chloride and you dissolve it in water, for example, or it's molten, i.e. you heat it to the point whereby it melts, so you take sodium chloride to over 801 degrees, what happens is the force between the ions is broken. So the electrostatic force is broken and the ions are free to move. And because the ions are free to move, like this and this and this and this and this, because the forces have been broken because it's dissolved or it's molten, and electricity is the movement of charge, the ions can move. So ionic compounds, when dissolved in water or when ionic compounds are molten, do conduct electricity just because the ions are free to move.